Hi everyone. This is actually part 2 of our gases and stoichiometry, and this is really gases, stoichiometry, and PV equals NRT. As before, please take out problem book 716, a calculator, and a pen or pencil. So if you don't have it right now, pause the video, get it out, and follow along with me. Thanks for getting your supplies. Let's work on one more problem. We've already done B and D in part 1 of this series. If you haven't watched part 1, watch that first and then come and watch this one second. So we're going to solve 11H together. And 11H is a combination of unit analysis and PV equals NRT. So one of the things you have to do on the test is be able to figure out what equation to use. Am I using unit analysis? Am I using PV equals NRT? Am I using P1V1 equals over N1T1 equals P2V2 over N2T2? So how am I going to figure that out? So let's read H and kind of give you some clues at how you know which one to do. And so it says if 100 liters of hydrogen react, how many grams of ammonia will be produced at 2 atmospheres and 25 degrees Celsius? So when I read this, I notice a couple things. It's not a P1V1 over N1T1 equals P2V2 over N2T2 because I don't have 2 pressures or 2 temperatures or 2 moles or anything. I just have 1. So that's one clue. So I'm not going to be using the P1V1 N1T1 equals P2V2 over N2T2. I may probably and am going to be using PV equals NRT. So that's from reading that. The other thing which is different from the other PV equals NRT problems is that I have 2 different gases. That's very, very important, okay? It's 100 liters of hydrogen gas. And I also want to know the grams of ammonia. So I have 2 different gases, which tells me I'm going to need a balanced equation, which I do have at the top of the page. So what happens if I tried to solve this by just using unit analysis? How would I know that I needed PV equals NRT? So if I read this, it says how many grams. I could start this out and go grams of NH3. And then I start with 100 liters of H2. And now I want to get to grams of NH3. So you might think, well, I remember last video, we learned 22.4 liters equals 1 mole. But hopefully you learned also from last video that 22.4 liters equals 1 mole only at STP. This is not at STP. How do I know? Because we're not at 1 atmosphere. It says 2 atmospheres. And we're not at 273.15, which is 0 degrees Celsius, because we're at 25 degrees Celsius. So I can't use 22.4 liters equals 1 mole. So what could I use? Well, I can still use the balanced equation and use the numbers in front represent liters because I am at 2 atmospheres and 25 degrees Celsius. So I'm at a set temperature and pressure. So from this balanced equation, I know that there are 3 liters of hydrogen needed to make every 2 liters of ammonia gas. Okay. So there I have that. And now I need to go from liters of ammonia to grams of ammonia. So now you might figure out that you're going to be stuck because I can't use 22.4 liters for 1 mole. I can't use any molarity. There's no molarity given. I can't use the periodic table because I have to have grams per mole, and I'm in liters, I'm not in moles. So right now, I'm kind of stuck. I can't go farther, so this is not just a unit analysis problem. It must also be a unit analysis plus PV equals NRT. But I'm glad I kind of started this because I'm going to use this information. So let's finish this, but it won't give me grams. It will give me liters of NH3, which I am going to need. So if you take out your calculator, 100 times 2, excuse me, divided by 3 is 66.666666. So give it a few numbers, and we don't want to round too soon. So 66.666 liters of ammonia. So that's what I have. Now I am going to have to still use P equals NRT. So now I can plug the things I know into my PV equals nRT equation. So my pressure is 2 atmospheres. My volume is 66.6667 liters. My moles, I don't know the moles, so that's going to be on my unknown. But you might say, but Miss Backus, it's asking for grams. It's not asking for moles. Well, I'm going to have to get to moles, and then from moles, I'm going to get to grams. R is 0.08206 liters, atmospheres, moles, Kelvin. And I'm at 25 degrees Celsius, which is 298.15 Kelvin. So now I solve for N. If you do the math, 2 times 66.6667 liters divided by 0.08206 divided by 298.15 will give me 5.4497 moles. And notice I'm not rounding yet because I want to round at the end. But once again, I'm still not at grams. And I have to be careful. What am I at? I'm at moles of ammonia. All right. So now I have to keep going because I'm at moles of ammonia, but I wanted grams of ammonia. So I also still have to use the periodic table. So I used a unit analysis to start with here. And then I went to PV equals nRT, and now I'm going to use unit analysis again. So I'm going to multiply this number by the molar mass of ammonia. Sorry that I'm running out of space here. I want to fit it all in. So now I take my moles, multiply it by 17, that's a 1.031, that's the molar mass of ammonia, and then I get the answer of 92.8 grams of ammonia, which happens to be the answer given in the problem book. All right? So there you have it, combination of unit analysis and PV equals nRT. We're going to try this problem once more to show you another approach that you might have done. So let's try this one more time, because you might have said, Miss Backus, what if I started with PV equals nRT? Would that have been easier? So let's try it that way. PV equals nRT. I'm going to start with that. Okay, maybe that would have been faster. So pressure is 2 atmospheres, so I'm going to plug that in. The volume is 100 liters. Uh-oh, this is where you have to be careful. It's 100 liters of hydrogen gas, okay? I have grams of ammonia, pressure of ammonia, temperature of ammonia, so I cannot use hydrogen here, okay? If I use hydrogen here, you have to be careful. It's okay, but then when I find the N, I am not going to be finding the moles of ammonia. I'm going to end up with moles of hydrogen. So you have to follow the units with the type of material there are. So if you have a problem that has hydrogen and ammonia, be careful. You should label it not just liters, but liters of hydrogen. So this won't be N of ammonia. This will be N moles of hydrogen. So I could solve for moles of hydrogen first, then do stoichiometry next. So you can do it a different way, but be careful. If you use 100 liters of hydrogen here, this is not moles of ammonia, this is moles of hydrogen. So this method works if you start this way, but then you will solve for moles of hydrogen. And I'm not going to do the whole math for this, but you would get an answer that would be moles of hydrogen. And then you would have to use your balanced equation and say there's 3 moles of hydrogen. Remember, we didn't really solve this yet. 3 moles of hydrogen for every 2 moles of ammonia. Sorry about that. And then we could change that into grams. And if we bothered to figure out what this number was, you would find you get the same answer of 92.8 grams of ammonia. So it doesn't matter which you start with, but you have to be careful. If you start with PV equals nRT, if this volume is for hydrogen, then this is the moles for hydrogen. If the volume is for ammonia, then the moles will be for ammonia. So that's the only thing. The volume and the moles have to be of the same material. The pressure has to be of that material also. The temperature has to be of that material also. All right. So they have to be the same. You can't change from one to the next. So you can solve it either way. You can start it with unit analysis first and then go to PV equals NRT. Or you can start with PV equals NRT, which is kind of hard to read here, but that's what that said. PV equals NRT. And then do unit analysis next. So either way would work. So let's look at a couple more problems on the same page. So look at I. Notice it's liters of hydrogen, how many grams of ammonia, and it gives me conditions that are not STP. So I is a similar problem. So I'm going to have to use unit analysis and PV equals NRT for I. And then look at J. J is also the same thing. I'm going to have to do unit analysis and PV equals NRT to solve J for problem book 716. All right, so the answers are given to you. So you should be able to check to see if you got them right or not. And then if you have questions, ask me in class. Thanks for listening.